Question 1. Okay, guys, this is just hopefully straightforward surd question. So rationalize the denominator. So I need to do 8 plus root 3 over 2 minus root 3 times the conjugate 2 plus root 3 over 2 plus root 3, like this. And then we do top times the top. This gives me a times 2 is 2a, a root 3 plus 2 root 3 plus root 3 times root 3 is 3. And then all over, this guy becomes 4 plus 2 root 3 minus 2 root 3 minus 3. The bottom is actually just going to be 1, which is nice. This is equal to 2a plus 3, 2a plus 3 plus a root 3 plus 2 root 3. So you could put that, if you want, guys, as a plus 2 root 3, although you don't have to do that. Okay, and then he says this equals 11 plus b root 3. So this equals 11, actually I'll just do it down here, 2a plus 3 plus a plus 2 root 3 equals 11 plus b root 3. Now in these questions, guys, the key is that the rational numbers equal the rational numbers and the irrational numbers, hence the root 3's, equal the root 3's. So I can say 2a plus 3, 2a plus 3 equals 11, 2a equals 8, a equals 4, and then here I can say a plus 2 equals b, because I can basically remove the root 3's. We know a is 4, so 4 plus 2 equals b, so b equals 6. Okay, that's question 1. Question 2. Write fx in this form, basically complete the square. Okay, so I'm going to take out the minus, guys, take out the minus, and I'll have minus x squared and then minus 4x, like this, plus 7. Okay, then this equals minus, I'm going to open the square bracket, this becomes x minus 2 squared, and I subtract 4, close the square bracket, plus 7. This becomes minus x minus 2 squared plus 4, minus minus is plus, and then plus 7, and then this equals just 11, that's the 11, and then minus x minus 2 squared. Okay, b, I. Hence or otherwise find the maximum value of f of x. Okay, so the whole point, guys, of completing the square is you find the maximum. So the maximum is just this 11, because it's when this bit is 0. So it's just 11. And then the value of x for when this occurs, well, when does this equal 0? Well, when x is 2. So it's just 2. It's basically this number, but the opposite sign. And there we go. That is question 2. Right. Nice, easy start, guys. No doubt this is going to get a lot worse. Question 3. Differentiate. So we've y equals e to the 2x times x squared plus 1. This is a clear product rule. So we'll say u is equal to e to the 2x, v is equal to x squared plus 1. Differentiate this, u dash is equal to 2e to the 2x. It's e to the 2x times 2, so 2e to the 2x. And v dash is 2x plus 0, which is just obviously 2x. Okay, then I can say dy dx is this times this plus this times this. So this times this is 2x e to the 2x plus this times this, which is 2e to the 2x times x squared plus 1. And that's it. That's all I have to do. Easy. Okay, b. The straight line L is the tangent to the curve with equation this. At the point when x is 0, find the equation in this form. Okay, so this is not bad, guys. We need a point. We need a point. And we need a gradient. Okay, so the point, guys, we get from subbing. Well, the point is it's when x is 0, and then we sub that 0 into y here. So what is y? I'll call it y of 0. Well, it's e to the 0 times 0 plus 1. That's 1 times 1, which is 1. So it's just 1. So the point is 1. The gradient, well, I want dy dx when x is 0. So dy dx, I'm just going to write it like this, when x is 0, is equal to, this becomes 0. So that's just, 0, plus 2 times e to the 0, which is 1, times, again, 0 plus 1, which is 1. So it's 2 times 1 times 1, which is 2. Okay, so now I have my point and my gradient. And then it's actually simple, guys, because we have the y-intercept, so I just have to write y equals mx plus c, which is 1, 2x plus 1. Okay. Next question. Question 4. F of x is this. When f dash of x is divided by x minus 2, the remainder is 5. Given that x minus 2 is a factor of f of x, find the value of a and the value of b. Okay, so quite a common question, guys, in any maths that I teach, actually. There's two variables that you don't know, a and b, and you'd find them both. And the way you do it is by finding two equations and solving them simultaneously. So one equation is obviously going to be got by this, and the other equation is going to be got by this. So let's do this one first. X minus 2 is a factor of f of x, so that means f of 2 equals 0. This is the factor theorem, guys. If x minus 2 is a factor, then f of 2 equals 0. Okay, so f of 2 is just 2 times 2 cubed plus a times 2 squared plus b times 2 plus 18 equals 0. Here we have 8 times 2 is 16 plus 4a plus 2b plus 18 equals 0. 4a plus 2b plus 34 equals 0. This is one equation. Then he says f dash of x. Okay, so first we need to get f dash of x. So f dash of x is multiplied by the power 6x subtract 1 from the power squared plus 2ax plus b, that becomes 0. Okay, then same thing, guys. The remainder is 5, so this is the remainder theorem. So f dash of 2 must equal 5. Okay, so this equals 5. Okay, so when I sub in 2 in there, I'm going to get 6 times 2 squared plus 2a times 2, 2a times 2, plus 6, and that was equal 5. Okay, that's 4 6s is 24 plus 4a, 24 plus 4a plus 6 are, sorry, it's not a 6, is it? It's a b. Sorry, plus b. 4a plus b equals 5. Now, I'll just write it up here. This is 4a plus b, and then we'll subtract the 5 plus 19 equals 0. That is our second equation. Now, guys, it's simultaneous equations. Let's just solve this. I can just put the 4a under here. 4a plus 2b plus 34 equals 0. Line underneath. Same sign, subtract to get rid of the a's. Minus b minus, this would be 15 equals 0. So b equals negative 15. If b is negative 15, sub it into one of my equations. Let's go with this one. So 4a plus, well, minus 15 plus 19 equals 0, 4a plus 4 equals 0, and then 4a equals minus 4, a is equal to negative 1. Okay, so that is our answers for A and B. Okay, part B. Express f of x as a product of linear factors. Okay, so we know that x minus 2 is a factor, so I think I'll do this the old-fashioned way, guys, which is to divide by this x minus 2. So x minus 2, like this. I have 2x cubed plus ax squared. Now a we know is minus 1, so it's minus x squared. B we know is minus 15, so it's minus 15x plus 18. Okay, I'll just take this down a little bit so I have some space. Then we do long division. I'll do this quickly, guys, but obviously you need to know how to do this. X into this goes 2x squared. This times this is 2x cubed. 2x cubed minus 4x squared. Line underneath, subtract 0. That becomes minus, so it's positive 3x squared. Bring this down, plus 18. This into this goes plus 3x. This times this is 3x squared minus 6x. Line underneath, subtract. Careful, it's plus, so then becomes minus 9x plus 18. X into that goes minus 9. Minus 9 times x, minus 9x plus 18. And then what I expected, this becomes 0, which means I've done it right, because I shouldn't have any factors or any remainder. Okay, so therefore f of x equals, I'll just do it over here, guys. F of x equals x minus 2 times this quadratic, 2x squared plus 3x minus 9. And then you have to, because this is linear factors, you have to factorize this quadratic. I'm going to do it up here, guys, my quick way. You do it your way. Make sure you get it. We're going to do the AC method. Fine, but just do it right. Okay, 2x and x, 3 and 3, plus and minus. So I have 2x minus 3, and I have x plus 3. Okay, that is part B done. Part C, hence use algebra to solve the equation. Okay, so this, guys, is then very easy. Once you've done this, we've done the hard bit. That means that x minus 2 equals 0, or 2x minus 3 equals 0, or x plus 3 equals 0. So my solutions are x equals 2, x equals 3 over 2, or x equals negative 3. Okay, that, guys, is question 4. Show that log 32 base 4 equals that. Okay, so guys, you cannot use the 5 over 2. We need to turn this log 32 base 4 into 5 over 2. So how we'll do it is, I think, why don't we turn it to base, we'll change the base to base 2. So that's 32 base 2 over log 4 base 2. That's our change of base rule. And then that is equal to log 32 base 2 is 5, and log 4 base 2 is 2. So there, we've shown it, QED. Okay, part B. Hence or otherwise find the exact solutions of this equation. Okay, so we have, well, we know this is 5 over 2, and the rest we'll deal with. Okay, so this is log x base 2 minus log 32 base 4, which, sorry, that is 5 over 2. So it's minus 5 over 2 plus, now if this is okay with everyone, guys, I'm going to do log 16 base x to the power of a quarter. This is my log power rule. I can bring this quarter up here as a power. Okay, then let me just tidy up this thing over here, so that's minus 5 over 2, plus, now 16 to the power of a quarter, guys, is 2. It's the 4th root of 16. So this is actually log 2 base x equals 0. Okay, now I have a situation where I have 2 logs but different bases. So let's change the base. And I think the natural thing to do, guys, would be to change the base to base 2 of this guy. So this is log x base 2. This is minus 5 over 2. And this I'm going to change to log 2 base 2 over log x base 2. And this equals 0. Okay, then guys, what I'm going to do is, well, actually, that's 1. So why don't I just do that first? So log x base 2 minus 5 over 2 plus 1 over log x base 2. Why is that 1? Well, 2 to the power of 1 equals 2. Anything to the log of x to the base x is equal to 1 always. Okay, now the next step, guys, because I have this underneath the line, I'm going to multiply across by log x base 2. So everything. This becomes log x base 2 times log x base 2. Now, guys, do not do anything silly like that. It's the whole thing squared, because we're multiplying this by this, whole thing squared. This then becomes 5 over 2 log x base 2. And then this becomes 1, because obviously that removes the denominator. Okay, I think I'm going to multiply by 2, guys. 2 log x base 2 squared minus 5 log x plus 2 equals 0. Then, nice thing to do is let y equal log x base 2. Okay, so now I have a quadratic. 2y squared minus 5y plus 2 equals 0. Factorize this. 2y and y, 2 and 1, minus and minus. This is 2y minus 1 times y minus 2 equals 0. This is y equals 1 over 2, and this is y equals 2. But y is log x base 2, so that equals a half, and this is log x base 2 equals 2. So x is 2 to the power of a half. X equals 2 to the power of a half, which is root 2. So x equals root 2. Or x equals 2 to the power of 2, 2 squared, which is equal to 4. So those are my two solutions. Question 6, complete the table of values for y equals x minus 3 over x squared. Okay, so guys, depending on your calculator, you gotta know how to do this. So we go to, in my calculator at least, go to function, and then we go to define f of x, and here we write in the x minus 3 over x squared, like this. Then we go back home, and we go to table, and our f of x is going to come out here. So we just type in the numbers we want. 1, I want 1, I want 1.5, I want 4, and I want 5. The error there for g of x, guys, is because I don't have a g of x defined. So it's minus 2 minus 0.1666, so that's minus 2 minus 0.166, well, I guess it's like that, 3.81, sorry, 1 decimal place, guys, so it's, well, he says where appropriate, guys, so whatever. This one is 3.8, and then finally this one is 4.9. Okay, 4.9. Now I could write this one as minus 0.2, but I actually think it's not appropriate. So let's leave it like that. Okay, on the grid opposite, draw the graph of this. So now we just draw it. So we put in these points. 0.5 is here, negative 11.5 is here. 1 minus 2, 1 minus 2. 1.5 minus 0.166 or something around there. 2, 1.3. 1.3 is around here. Just be careful, these are going up in 0.2s. 3, 2.7. 3, 2.6, 2.7. 4, 3.8. 3.8. 5 is 4.9 here, and 6 is 5.9, which is there. Now he says from 0.5 to 6. So guys, don't go any further. Start here and finish here. Now guys, this my pen here is notoriously not good at drawing these things, so do better than what I'm about to do here. Okay, that's as good as I'm gonna get, guys. Obviously, try not to do what I did there. Okay, that is this. Okay, part C, I'll do here, guys. This is the hard bit. By drawing a suitable straight line on the grid, obtain estimates to one decimal place of each of the two roots of this equation. Okay, so we're trying to solve 2x cubed minus 6x squared plus 3 equals 0. Now what we're trying to do is we are trying to get this, right? We're trying to get this equation. So we're going to turn the left into this, because then we'll have the graph on the left and hopefully some kind of straight line on the right. I think the natural thing for me to do here, guys, is divide by, if I divide by x squared, that'll give me the 3 over x squared. I'll have 6 here and I'll be able to deal with something here. So let's divide everything by x squared. Divide by x squared. Divide by x squared. Okay, this gives me 2x, because I'm dividing this by x squared, minus 6 and plus 3 over x squared. Okay, and this equals 0. Now let's just bring over the 6, so that's 2x plus 3 over x squared equals 6. Now we're nearly there, guys, although actually we're not. It's minus. I need this to be minus 3 over x squared. So what I'm actually going to do is I'm going to bring this over to the right. So what I'm going to do is I'm going to bring, well, let's do that first. 3 over x squared to the right. So now I have minus 3 over x squared. And actually, I can bring the 6 back here. So that's 2x minus 6. So I could have just left that there. Okay, and now let me just move over to the right here, guys, so I can keep on one screen. So I now need to add x to both sides, because obviously I need an x for the right here. So this will give me 3x minus 6. So I've added x to the left, and I'll add an x to the right, x minus 3x, 3 over x squared. Okay, so I need to draw, and I'll write it here, draw y equals 3x minus 6. How do I draw y equals minus 3x plus 6? Well, I just like to get two coordinates. When x is 0, y is minus 6. So there we go. X is 0, y is minus 6. And when x is, I don't know, let's put in 2. When x is 2, well, when x is 2, y is 0. When x is 2, y is 0. Perfect. So there. So I'm going to go from here through there and through there. Now where they meet, which would be here and here, these are my solutions, but they're the x coordinates. So this guy here is around 0.8, 0.85, and this guy here is around 2.85, something like that. So does he want one decimal place. So I'll go x equals 2.8 or x equals 0.8. And those are my two solutions. Okay, that, guys, is question 6. In arithmetic series P, this first term, a common difference d, nth term u of n, given that u of 5 is this, u of 8 is this, show that d is equal to x minus 1. Okay, so fine, guys, I think this is okay. Let's do it here. So if we have u5 and we've got u8, we know that u5 plus, if I do u5 plus d, I'll get u6, plus d again, I'll get u7, and plus d again, I'll get u8. So u5 plus 3d has to equal u8. Okay, so then I have 4x plus 6 plus 3d equals u8, 7x plus 3. Then I'll just subtract these over here. So that's 7x minus 4x is 3x, and 3 minus 6 is minus 3. Divide everything by 3, and I get d is equal to x minus 1. Okay, fine. I find a, which is the first term. Okay, well, I know a plus 4d gives me u5, which is 4x plus 6. Why? Because the first term plus 4 differences will give me the fifth term. Now I know d is x minus 1, so a plus 4 times x minus 1 equals 4x plus 6. A plus 4x minus 4 equals 4x plus 6. Divide or subtract 4x from both sides, and then a equals 6 plus 4, which is 10. Okay, B. Given further, u9 is 42, find the value of x. Okay, so similar kind of thing, guys. I can just say u8, my 7x plus 3, plus my d, plus d, which is x minus 1, has to equal u9, which is 42. 7x plus x is 8x. 42, this is 3 minus 1 is 2. 42 minus 2 is 40. And then x is equal to 40 divided by 8, which is 5. Okay, finally, part C. The sum of the first n terms of p is s of n. Find the value of n for which s of n plus 1 is equal to 12 un plus 18. Okay, fine. So S of n, guys, our S of n formula for arithmetic is n over 2, 2a plus n minus 1 d. Okay, now he wants S of n plus 1. So S of n plus 1 is equal to n plus 1 over 2. 2a, which is 20, plus n minus 1 times d. Now d, guys, is 4, because d, let me just write it here. D is equal to x minus 1, x is 5, 5 minus 1 equals 4. So d is equal to 4. So this is s of n plus 1. And actually, sorry, I made a mistake, guys. It's, sorry, that is 4. It's n minus 1d, but it's n plus 1 minus 1. So this is actually, let me just delete this. This is n plus 1 minus 1, which is actually 0, but let's just leave it for now, times 4, close this, I get n plus 1 over 2, and I have 20 plus 4 times n, that's 0, is 4n, like this. I guess I can go a little bit further, guys, and say this is equal to m plus 1 into, divide by 2, and I get 10 plus 2n. Okay, let's leave that for now. Then I have un, okay, let's just write un here. Un is a plus n minus 1d. n minus 1 times 4. Simplify this. 10 plus 4n minus 4. 6 plus 4n. Okay, down here, I now form the equation. This n plus 1 times 10 plus 2n equals, where does this equal 12 of these? So 12 times 6 plus 4n plus 18. Okay, so that's a kind of a weird equation to solve, but it's just a quadratic which we can solve. So let's just multiply everything out. I'll just go down here, guys, and this is now just a quadratic that we need to solve. So 10n plus 2n squared plus 10 plus 2n equals 72 plus 48n plus 18. Divide everything by 2. Let's do that first. So I get 5n plus n squared plus 5 plus n equals 36 plus 24n plus 9. Okay, we then have everything to the left. N squared. We have 5n plus n is 6n minus 24n is minus 18n. And then I have a 5 up here. This is 45, so 5 minus 45 is minus 40 equals 0. Factorize this. This is going to be 20 and 2, guys, so it's going to be n minus 20, and then n plus, hang on, have I made a mistake, guys? N plus, n minus 20 and n plus 2 equals 0. So n equals 20 or n equals negative 2. Now it is the nth term of a sequence, so it has to be a positive integer. So I can just reject this one. Reject. Therefore, n equals 20. A particle P moves along the positive x-axis at time t seconds. The velocity is given by this. The time t seconds P is at the point with coordinates x0. Given that at time t equals 0, P is at the point, okay, find the maximum value. Okay, that's too much words for me to understand. Okay, let's have a look. This is V. Fine. Given that at time t equals 0, P is at the point with coordinates 5, 0. Find the maximum value of x. X is this. Okay, so basically, guys, we are trying to find this is the displacement. We are trying to find the displacement. So if you remember our SVA thing, this is differentiate and this is integrate. So if I have the velocity, I need the integral. So what do I need to do? I need integrate v. So the integral of this is 3 plus 5t minus 2t squared. And this will give me s, the integral of this dt. This becomes 3t plus 5t squared over 2 minus 2t cubed over 3 plus c. So now, because this is s, we need to find c, and we're going to find it from the information that he gives us, which is 5, 0. So this means that s is, he's only moving along the x-axis, guys, so the y-coordinate is always going to be 0. So that y-coordinate is not the time, that's the y-coordinate. It's almost irrelevant here. It's just, it means s is 5. So s is 5 when t is 0. So 5 equals 0 plus 0 minus 0 plus c. So c is equal to 5. So that means s is equal to this 3t plus 5t squared over 2 minus 2t cubed over 3 plus 5. So this is s. Okay, now he wants to find the maximum value of S. Okay, so let me have a think, guys. This is S. How do we find the maximum value of this? Okay, well, the maximum occurs when ds dt is equal to 0. So let's write over here. Max S when ds dt equals 0. Okay, now what is ds dt? Well, we actually have ds dt. It's this v here. So I can say where this equals 0, 3 plus 5t minus 2t squared equals 0. Change the signs, guys, just for fun. 2t squared minus 5t minus 3 equals 0. Factorize this. I'm going to do it my quick way. 2t, 3, 1 minus plus. So it's 2t plus 1 times t minus 3 equals 0. Sorry, this equals 0. So t is equal to negative a half, and t is equal to 3. So it's definitely going to be the 3 that I want, guys. You also can consider this graph, the graph of this cubic. It's a negative cubic, so it's actually going to go down, up, and then down. So the maximum is here. The negative a half is actually there, but that's definitely wrong because it's a minimum. And it's a negative t, so that's of no use. So we're going to use the t equal to 3. So I want to get s of 3. So s of 3 is equal to, and then I'm just going to sub in 3 in here. So it's 3 times 3 plus 5 over 2 times 3 squared minus 2 over 3 times 3 cubed plus 5 equals 9 plus 9 times 5 is 45 over 2 minus one of these 3's cancels. That's squared. 9 times 2 is 18 plus 5. May as well finish this, guys, in my head. This is going to be 9 minus 18 is minus 9. So I have minus 9 plus 5 is minus 4. Minus 4 plus 45 over 2. That's minus 8 over 2 plus 45 over 2 gives me 37 over 2. So this is equal to 37 over 2. That's the max S. Okay, now he says justifying that this is a maximum value. So just be careful here, guys. Justifying this is a maximum value. I should probably go over here. When he says justifying, he wants the second derivative, guys. So let me just write here. If max d d2s dt squared is less than 0. So I'll say that here. I'll get the second derivative, d2s dt squared. That is equal to, well, that's just the derivative of this, guys. The derivative of that thing there, which is 0 plus 5 minus 4t. At t is equal to 3, it's 5 minus 4 times 3, which is equal to 5 minus 12, which is minus 7. As negative 7 is less than 0, it is a max. It is a max. So that's my answer, and that's my justification. Okay, guys, hope that makes sense. That is question 8. The line L1 with this equation passes through the points P and Q. Find the value of A and B. Okay, so guys, that I think is okay. Let me do it here. So basically he's saying when y is 6, what is x? Okay, so let's do that. 6 plus 2x minus 4 equals 0. Rearrange. 2x equals negative 2 and x equals negative 1. And then this is when x is 3, what is y? So y plus 2 times 3 minus 4 equals 0, y is equal to 6 minus 4 is 2, negative 2. Okay, so therefore a equals negative 1 and b equals negative 2. Part B. The line L2 passes through the point P and is perpendicular to L1. Okay, so now guys, I always suggest to draw. So here we have this line, minus 1, 6, and 3, minus 2. So it's minus 1, 6, and 3, minus 2. It's going down this way. Now, I'm not going to put exactly to scale, but whatever. This is going to be minus 1. This is P, minus 1, 6. And this is Q, which is 3. Q is 3 minus 2. 3 minus 2. This is Q. Okay, L2 passes through P and is perpendicular to L1. Okay, I probably should have moved this a bit, guys. Let's just put it here. Sorry, guys. Okay. Let me move this point. Okay, that's a bit better. Okay, so this this line L2 passes through P and is perpendicular. So there's another line. Let's draw it here, like this, perpendicular. That doesn't look very perpendicular. Okay, there we go. This is L2, and this is L1. The point R with coordinates EF lies on L2 such that PR is 6 root 5. Okay, so R is here, and then PR is 6 root 5. Find two possible pairs of values of E of F. So where could R be? Well, it could be here or up here somewhere, but we'll figure it out using algebra. So, okay, firstly, distance formula. So R at the moment is EF. So this is EF. So the distance between those 2 points is 6 root 5. So we know the distance formula, guys, is this minus this squared. So minus 1. Let's actually go the other way around. I'll go this minus this. So I'll have E plus 1 squared. And then this minus this. So plus F minus 6 squared. So that's the distance between those 2 points. And that must equal 6 root 5. Square both sides. I get E plus 1 squared plus F minus 6 squared equals 6 times 6 is 36. Root 5 times root 5 is 5. 5 times 36 is 180, I believe. Okay, fine. That is equation 1. I need a second equation, guys, because I have 2 variables, E and F. How do I get it? Well, the other key point, guys, is that it's perpendicular. So let's get the gradient. I'm going to get the gradient of PQ, M PQ. That is this minus this, so minus 2 minus 6 over 3 minus minus 1, which is minus 8 over 4, which is minus 2. So that gradient is minus 2. My gradient of L2, let's call it ML2, is equal to the negative reciprocal, so it's positive, and it's going to be a half. Now, I did say it's not to scale, guys, so don't freak out. So the gradient is a half. So if I do y2 minus y1, let's do, okay, I can do f minus 6, y2 minus y1, over e plus 1 is equal to 1 over 2. And then let's cross multiply. I can do 2 times f minus 6 equals e plus 1. Okay, now the fact that this equation, guys, has an e plus 1 in it, let's just leave that e plus 1 like that. And let me just go over here. I'll just solve it like this. So I'm going to sub that 2, and let's call that 2f minus 12. I'm going to sub that 2f minus 12 into that. So this becomes 2f minus 12 squared plus f minus 6 squared equals 180. Okay, multiply all this out. 4f squared minus 48f plus 144 plus f squared minus 12f plus 36 equals 180. Okay, simplify this. That's 5f squared. 48f minus 12f is 36f. No, sorry, it's minus, so it's minus 60f. Okay, that's nice, because hopefully this will cancel. 144 plus 36 is actually, okay, that's particularly nice, guys, because that's 0. Okay, so this equals 0, because that's 180 minus 180 is 0. Okay, divide by 5, f squared minus 12f equals 0. F into f minus 12 equals 0. So f equals 0, or f equals 12. If f is 0, what does e equal? Well, let's go back to here. E, let me write it like this. E equals 2f minus 13, because if I subtract the 1, then for this guy, e is equal to negative 13, so 2 times 0 minus 13. And here, e is equal to 24 minus 13, which is 11. So the two pair of points are, it's EF, so it's minus 13, 0, or 11, 12. Okay, that's part B, guys. I'll do part C in the next video. For part C, it says find the area of triangle PQR given that e is less than 0. So if e is less than 0, we're choosing this e, the minus 13, which means that f. So this is now minus 13, 0. Okay, I'm going to, guys, remove all of this, just so we have some space to work with. Okay. He says find the area of triangle PQR. So PQR is just this here to here. So this is a right angle. We know this length here is 6 root 5. So area of a triangle is a half base times height. The height, well, it's going to be a half this times this, because they're the perpendicular ones. So I just need PQ. PQ is distance between 2 points. This minus this, so 3 plus 1 squared, plus this minus 2 minus 6 squared. That is equal to the square root of 4 squared, which is 16, plus 8 squared, which is 64. That is 80. So this is root 80. So the area of our triangle, area equals a half base times height. So it's a half 6 root 5 times root 80. And that is equal to, that go into that 3 times. So it's 3, so that's 3 root 5. And this is actually root 16 times root 5. And that is equal to 3 root 5 times 4 root 5. 3 times 4 is 12. Root 5 times root 5 is 5. Use a calculator if you need to, but that is 60. Okay, finally, part D. Let's do it here. The points P, Q, and R lie on a circle. Find the coordinates of the center C. Okay, so guys, I have seen this type of question before. If these are on a circle, now let me try and draw the circle here. Okay, I need to make that bigger. That's pretty close. Okay, now if he says, guys, that if these 3 points are on the circumference and there's a right angle there, so I've seen this type of question before, that means that this is the semicircle. Sorry, this is a diameter, because angle in a semicircle is 90 degrees. So this here, this is the key to the question, this is a diameter. Okay, now what does he actually want? He wants the coordinates of the center of the circle. Okay, so, well, it's only 2 marks. So I guess the first mark is understanding this, and then you realize, well, the center is just the midpoint of R and Q. Midpoint of R and Q. And that's just going to give me the answer. So it's just minus 13 plus 3 over 2, comma, 0 minus 2 over 2, which gives me minus 10 over 2 is minus 5 and negative 1. Okay, that, guys, is question 9. Okay, so we're given all this, guys. Find a, b as a simplified expression in terms of a and b. Okay, that, guys, is not difficult. A to b, we go down this way and up this way. So negative 2a plus b, so it's the opposite signs, negative 2a and plus b for this one, because we're going against the arrow. And then plus 3a plus b, because we're going to with this arrow, and we get a plus 2b. Okay, b. Prove OC is parallel to AB. Okay, if you're going to prove it, guys, you just kind of say at the start what you're doing. So I'm going to say if parallel let's say OC is equal to K times AB. So if they're parallel, they will just be a multiple of each other, essentially, because that means they're going in the same direction. So I need to get, I've got AB, now I need to get OC. So to get from O to C, along how we know, we're going to go up here and down here. So it's going to be 3a plus b, and then minus a plus 3b. And this gives us 2a plus 4b. Now you have to write it, guys, as, well, this is 2 times a plus 2b, which is equal to 2 times ab. Therefore, parallel. Okay, part C. The diagonals OB and AC intersect at point X. Okay, so let's draw that. This here to here. They meet at point X. Okay. Using a vector method, find the ratio AX to XC. Okay, so the way we do this, guys, is, if you've ever seen me do these in the normal IGCSE papers, is we go from A to X, but we go a few different ways. So one of them is, I'm going to say AX equals some fraction of AC. So it's like lambda times AC. And another way we can get there, let's do it over here. AX is also equal to AO. I'll go from A to O. And then some fraction mu, so this is our lambda mu question, mu times OB. Okay, so we're going to find AX using both of these methods and then equate them. Okay, so which do you want to do first? Let's go this one. So I need AC first. So AC, let's do this in a different color. AC is equal to, because I'm trying to find this AC. So AC is equal to minus 2a minus b So I'm going to go down here, plus OC, and we know OC is this, so plus 2a plus 4b. So AC, sorry, I just realized that's a mistake. It's minus 2a plus b. And then, well, yeah, the rest of it's right. Okay, so AC is actually equal to 5b. AC is equal to 5b. There is no a's there, so okay, that's interesting. So AX is equal to lambda times 5b, or 5 lambda b. Okay, that's our first AX. Our second one, this one, let's do it over here in red. AX is also equal to AO, that is our AO, which is our, again, minus, so minus 2a plus b, careful, plus mu times OB. Now OB is 3a plus b. So this is minus 2a plus b plus 3 mu a plus mu b. This is equal to, well, I'll just put the a's together, minus 2 plus 3 mu a, and then plus 1 plus mu b. Okay, so then I have my two x's here, and at this point I just go, well, the a is equal to a's and the b is equal to b's. Now in this case there is no a, so this must equal 0 because there's nothing here, and then this must equal 5 lambda. So this is actually easier than some of the ones I do in the normal IGCSE. This means minus 2 plus 3 mu equals 0, so mu equals 2 over 3, and 5 lambda equals 1 plus mu. Now we know mu is 2 over 3, so that's 1 plus 2 over 3. That is equal to, well, let's just do this. 5 lambda is 3 over 3 plus 2 over 3, which is 5 over 3. So lambda is equal to 1 over 3. So this, now just be careful, that's not the answer. He wants AX to XC. So therefore, AX to XC is equal to, if lambda's a third, that means like this is 1/3 here, and this is 2/3, because like that's 1/3 of AC. This is 2/3 of AC. So 1/3 to 2/3, or just 1 to 2. Okay, certainly not an easy question, guys, but not the worst possible vector question. Question 11. We are given this. There's a curve which is root x minus 2. This is a straight line x, y equals b. Given C and L intersect at the points with coordinates a, b, show that b squared equals a minus b. Okay, so they intersect here. This point, guys, is a, b. They intersect when they're equal. So let's just equate root x, this is part A, so root x minus 2, but x is a, so it's a minus 2 equals the line, which is b. Our y's are equal when x is a. There you go. Square both sides. A minus 2 equals b squared, and then, well, we're done. That's all you wanted. Q, E, D. Okay, I assume that's the easy part. Part B. The finite region, or is this region here, is rotated, so this is a volume of revolution, it's rotated about the x-axis to form solid S. Given that the volume of the solid is 50 pi, use algebraic integration to find the value of A and the value of B. Okay, this, guys, is tricky. It's the last question. It's definitely going to be hard. Okay, so the volume is the volume is, let's do our formula first. So it's pi times the integral of, okay, it's from a to b. Now, in this case, sorry, not a to this b, but our a, this is a, to our upper limit, which is 16. So it's a to 16 of y squared. So it's root x minus 2 squared. Okay, let's just put it in like that. Y squared. And then we also have to minus the line squared. Now be careful, it's this squared minus this squared. Like this. And then big bracket here, dx. Okay, then let's integrate this first, then we'll equate it to 50 pi, and then hopefully we'll get somewhere. So this is equal to pi times the integral from a to 16. This squared is just x minus 2, that's quite nice, x minus 2 minus b squared dx. Okay, integrate this, pi times integral of this is, now I want a big bracket here, guys, it's x squared over 2 minus 2x minus b squared x, because this is like a constant, close my bracket, from a to 16. Okay, now I'll do my pi, big square bracket, I'll do my round brackets. It's 16 squared over 2. It is then minus 2 times 16 minus b squared times 16, close brackets, minus, open brackets, then a squared over 2 minus 2a, and let me go over here, 2a minus, well, let's go 16, sorry, what am I doing? 2a, and then a in here, minus b squared a, close this, and then close, sorry, I don't do that, and then close this. Okay, this is the volume. Now he says this equals 50 pi. So let's equate this to 50 pi. So this equals 50 pi. Now immediately I can just cancel the pi's, which is good. Cancelled. Okay, then 16 squared over 2. Well, guys, actually 16 squared is 256. Divided by 2 is 128. Obviously, use your calculator. 128 minus 32 minus 16b squared. Careful here. This is minus a squared over 2 plus 2a and then plus b squared a. This equals 50. Let's subtract this first. This would be 96. So 96 minus 16b squared minus a squared over 2 plus 2a plus b squared a equals 50. Okay, so this is one equation with a and b. I cannot do anything with it yet, but I do have another equation, this one, a minus 2 equals b squared. So we got that from the first part. A minus 2 equals b squared. So instead of b squared, I'm just going to put a minus 2. Easy. So I have 96 minus 16 times a minus 2 minus a squared over 2 plus 2a plus a minus 2 times a equals 50. Let's multiply all this out. 96 minus 16a plus 32 minus a squared over 2 plus 2a plus a squared minus 2a equals 50. I guess let's tidy this up. Well, I have 2a minus 2a, which is gone. I have 96 plus 32, which is actually going to be my 128 again. So I have 128 minus 16a, and then a squared over 2 plus a squared, so that's like 2a squared over 2, so that would be plus a squared over 2, just, you can do that with your calculator, guys, minus a half plus 1 equals 50. Multiply across by 2, 256 minus 32a plus a squared equals 100. Rearrange a squared, let me just go down here, a squared minus 32a plus 256 minus 100 is 156 equals 0. And then factors of 156 to give me 32. Okay, I don't know what that is. Let me just do that with the calculator. Equation, polynomial, this 1 minus 32 and 156 is 26 and 6, so I get a minus 6 times a minus 26 equals 0. So a equals 6 or a equals 26. Now, once I get an answer, guys, I go back and I check, is there any reason that a can't be any of these things? Because a is obviously here. Well, look, a is obviously less than 16, and it even says it here. A is between 2 and 16, so a cannot be 26. So I'm going to say here, as a is less than 16, a equals 6. So therefore a equals 6. So b squared equals, coming from this guy here, guys, b squared is a minus 2. B squared is 6 minus 2. B is equal to, well, that's 4, obviously. Square root of 4 is 2. Now it's plus or minus 2, but again, let's go back. Is there any condition on b? Well, b is greater than 0. And again, it's kind of obvious it's above 0 from this graph. So same thing here. I'll say b is greater than 0. Therefore, b equals 2. So final answer, a equals 6 and b equals 2. Okay, obviously, guys, difficult question, but if you know what you're doing, you don't make any mistakes, it is a doable question. Okay, that's the paper, guys. See you for paper 2.